the previous lessons, we learned about equilibrium constant. And we learned that different chemical reactions will have different equilibrium constant. But what happened to the equilibrium constant when we make changes to those reactions? For example, like in this case, I have A plus B equal to AB, and we just make up a hypothetical number, equilibrium constant equal to 5. Well, based on the rules, every time you change the reaction, it will also change the equilibrium constant based on this 3 rule right here. First, if you flip the reaction, you will take the reciprocal of K to get the new K. Basically, the word reciprocal basically put 1 over it, okay? And that's the reason why the 1 over K is your new K right there. Now, what happens when we multiply a reaction by a number? Well, why would we do that? Because we want the coefficient to be the same so that we can cancel each other out. So if we multiply a reaction by a number, it will take K to the power of that number. For example, K would to the power of that number right there. And lastly, when you add 2 or more reactions, you will multiply all the K to get the new K. So basically, if you have 3 equilibrium reactions combined together, you would multiply them all. Let's look at an example to understand more about these 3 rules. Determine the equilibrium constant for the reaction below, this one here, using the chemical reaction above. So basically, these 2 chemical reactions will combine together in some way to make this reaction, but we don't know what the equilibrium constant is going to be. So let's look at something that's unique about this reaction. Well, first of all, I have 2AB2 right there, okay? So we look at the reaction A plus 1/2 B2 equal to AB, and we have A plus B2 equal to AB2. So I know for sure from here, this B2 must be over here. So I'm not going to do anything about this reaction, except for the fact that it is being multiplied by 2, right? So therefore, for sure, I have to multiply this by 2. So what am I going to have? Well, I'm going to have 2A plus 2B2, and that's going to equal to or make 2AB2, just like we have the 2 right there. So now we get that part down. Now that we have AB2 is on the product side, and it has 2 of it, let's focus on something else. Let's look for the other thing that's unique. Well, first of all, the B2 is in multiplies. Let's save that last. But we have AB right there. And how many AB am I going to have? 2AB. So I'm going to go find my AB. So look at the AB right there. It is on the product side when it's supposed to be on the reactant side. So I had to flip it, right? So I had to flip this right here. In this case, if I flip this, what happened? Well, let's do the flipping part. So if I flip this, right? Remember, we flip the reaction, it will take the reciprocal of it. So in this case, if I flip it, I would have 1 over 5, okay? Which is 1 over K in this case. Well, let's go back over here to look at this one. What happened when I put, before we continue with this reaction, let's go back over here. What happened to this K right here? Well, I've multiplied this by 2. So now my K would be 7 to the 2nd power because of that 2 right there. So let's go back and continue with this one. So in this case, what I have, I flip it, right? So I'm going to have this right here. So I have A plus B, and the other side will become the product, which in this case, A plus 1/2 B squared. That's good. But in this case, I have to have 2AB. So what I'm going to do next is I'm going to multiply it by 2. So the next thing is I'm going to multiply this by 2. So what I'm going to have is, and after I multiply by 2, I'm going to have 2AB and 2A plus B squared. So if I multiply that by 2, I would have to take the square root of this, as we did over here. So now, what do we have? We have 1 over 25. So that's the new K, and this would be 49. So that is the changes that we have made to our K constant because we have manipulated because of all the changes we made to the original reaction. So now let's combine them together. Okay, let's see if we can combine them together. Well, first of all, let's look at the A. So I have, what is this? I have 2A And that with 2a on the product side, it's gonna cancel out. That's why the a are gone over here, which is good. Then I have my b. Here I have 2b2, and here I have 1b2, and that cancel out. And this gives me the 1 left over b2, which is good. And then, okay, let's write it as 1b2 right there. And the only reactant left is the 2ab, which is exactly what we need. Good. Then all the reactant has been used or been looked at. Let's go to the product side. Well, on the product side, everything is canceled out on the top reaction except for on the bottom part, we have 2ab squared, and which is exactly what we're looking for. So we are pretty much done. So now we combine two of them together. If I combine them together, based on the third rule, we just multiply them together. So in this case, I'm going to use my new k, right? We're not using our old k anymore because we have changed the original reaction. So now we're going to multiply 1 over 25 times 49. And that would be 49 over 25. And that would be our new k right there. That would be the equilibrium constant for this reaction right here. And that's all we have to do. So those are the 3 rules of manipulating equilibrium constant.